Welcome student. Today I will discuss on function. What is function? Function or mapping. Let A and B be two non-empty sets. Then a function form A to B is a rule which associates each element of the A to some elements or all the elements of B. Mathematically, it is denoted by F such that A to B y equal to f of x. X be an element from A. That is A to B X denote all elements of A. Y all the elements in B. F. So y equal to Fx. Where A is called domain of F. B is called codomain of F. X pre-image. Image element. This is denoted by P of F. Another is range of F, which is collection of all Fx X belongs to A. Example. Let A equal to 1, 2, 3, 4. B equal to 2, 4. C equal to 0, 10. We define a function f for A to B by f of 1 to f of 2 equal to 4, f of 3 equal to 6, 8. So this is A, this is B. This is A, B. A contains 1, 2, 3, 4. B contains 2, 4, 6, 8. This is F. 2 equal to F of 1. 4 equal to F of 2. 6 equal to F of 3. In this way, we have defined this function F. Therefore, here domain of F is set, that means 1, 2, 3, 4. Codomain B 2, 4, 6, 8. Range of F also 2, 4, 6, 8. Because range are these elements F1, F2, F3, F4. These elements are called range. Here 1 is the pre-image, 2 is pre-image, 3, 4 are pre-image. 2, 4, 6, 8 are image. 2 is the image of 1. 2 is the image of 1. 4 is the image of 2. 6 is the image of 3. 8 is the image of 4. So, in this function, range and codomain are equal. Range set and the codomain set both are equal in this function. Range set 2, 4, 6, 8, codomain is also 2, 4. So range of F equal to codomain of F. Now we consider another example. By G of 1 to G of 2 equal to 4. That means here A, C, A 1, 2, 3, 4, C 0, 2, 4, 6, 8, 10. 1 goes to 2, 2 goes to 4, 3 goes to 6, now in this function domain A 1, codomain 0, 2, 4, 6, 8, 10. Range of G, not F. Range means this element G1, G2, G3, G4. That means 2, 4, 6, 8. These are the range. This is the range, these elements, these are the elements in range. 2, 4, now here range is a subset of codomain of G. Codomain this, range this. So range is a subset of codomain of G. So in general, what we can conclude? In general, we can, in the previous example, we see range set and codomain set are equal. Now, so in general, we can say range set equal to subset or equal to codomain set. There are so many functions. Here, for example, if we consider f from z to z, z is integers. F of x is equal to x square. This is function here. F of 1 is equal to 1 square 1. F of minus 1 is equal to minus 1 square 1. F of 0 is equal to 0 square 0, and so on. So there are so many functions. Here are so many functions. Now the question is, the two examples we have taken, domains are known here. We know the domain. Now there are so many functions whose domains are unknown to us. We have to find that domain. So how can we find easily domain of any function? Domain is very important part for a function. So the next task, how to find domain of a function. So we see. Now I make a table. From that table you can easily find out domain of any kind of function. Clear? So let I construct the table. So table first, table domain table for finding domains. Finding domain. Now form of a function condition. Form of the function f(x) is equal to px. Number 1, f(x) is equal to 1 by px by root over qx or 1 by root over px. f(x) is equal to px by qx. Number 4, fx is equal to log of px. Number 5, fx is equal to p c qx. So on. Now, when the form of function fx is equal to root over px, condition px greater equal to 0. That means if px greater equal to 0, then this function will be defined. By using this condition, we will find the domain set of that function. This condition in both the function, in both the forms, conditions are same. Condition is same. Like qx greater than 0 or px greater. Here qx not equal to 0. Here 0. Here px qx less equal to. Now I will solve few problems based on these conditions. How to find domain of any function, let we see. Before that, just remember two results. Result number one, x minus a, x minus b less equal to 0, where a less than b, then this implies a less equal to x. Example, x minus 2, so a is equal to 2, b 3, a less equal to b, less than b, so this implies 2 less equal to x, 3. X minus 1, x plus 1. Now see here x minus a, x minus b. That means both the product term be of the form x minus a, x minus b. Then we will consider whether a is less than b or not. Clear? So here x minus 1, x plus 1. So now see, this is x minus 1. Now this is x plus 1. So this term we have to write into this minus form. So this is x minus 1 and this is x minus of minus 1. So here a will consider the smallest of these two numbers. Smallest of these two numbers. So minus 1, b is equal to 1. So a is less than b. So then this is minus 1 less equal to x, less equal to. So if the inequality is of this form, if the inequality is of this form, then this inequality can be written a less equal to x less than b, where a must be less than b. This is number 1 result. Result number 2. Result number 2, if x minus a, in the previous result, this product term is less equal to 0. Now in this term, the product term is greater equal to 0. So in that also A less equal to B, less than B. So then this implies minus infinity, B less than H, less than plus infinity. So if this product term greater equal to 0, then this can be written minus infinity less than H, P, and this. For example, say x minus 2, so 2 less 3, so minus infinity. Yeah. Again. This is result number 2. Result 3, x minus a, x minus b less than 0. That means equality not hold. Then a also a less than b. And result 4, x minus a, x minus b, then minus infinity, problem number 1. Find domain fx now find the domain of definition of this function. Now this is of the form fx equal to so according to the table, if the form of the function root over px, then the condition, that means the function is defined when px greater equal to 0. So the function is defined when px px means x square plus x minus 12. So x square plus 4x minus 3x x plus 4 x minus 3. This is the result number 2. Product of two terms, linear term greater equal to 0, x minus 3 a 3 3 and minus 4 small x. So the condition minus infinity, the domain of f all x such that minus infinity 4 union by result 2. Problem number 2. Fx equal to x plus 2 by minus 2. This is of the form px by root over qx. So this is of the form root over qx. Qx 2. Now condition by the table, the condition qx strictly greater than 0. The function is defined if qx greater than 0. That means x square minus 2x plus x 0. X common, so x plus 1 0. Again by result 2, result 4, strictly equality sign not here, so strictly greater than 0. Now this is x minus or minus 1. A minus 1, 2. Domain union by result 4. Number 3, fx x square 5x x square 12. This is of the form px by qx. Qx the function defined when 0, that means x square by the table px by qx form, condition the denominator not equal to 0. So qx not equal to 0. Again by middle term x common, x minus 2 not equal to 0. So x not equal to 2, domain of x, all x, Problem number 4. Fx is equal to Fx is equal to 2 plus x minus x square. Again, this is of the form root over px. So, function defined when 0, 2 plus x minus x square, 0. That means x square, if we take this part to the right hand side, the inequality change. So x square minus x minus 2 less 0. So x square minus 2x, x common, 0. Now this is rule 1. This is rule 1. A minus 1, B 2. So this is minus 1. So domain by rule 1. Clear? Rule 1 formula. Next problem, fx is equal to log x square 5x. Now this is of the form fx is equal to log of px. Log of px. So by the table, the function will define when px greater than 0. That means x square 5x x square 3x x minus 3 so x minus 2 x minus 3 by rule 1. Domain of f union infinity. Clear? So today we have learned that definition of function, domain, codomain, range, and how to find domain of any function. Clear? So to get all for the day. In my next lecture video I will provide you your solutions of many problems regarding function. Okay. Take care all. Thank you.